Good afternoon, everyone. Nice to see some familiar faces in the crowd, and also thank you to HashiCorp for having Darryl and myself on stage today. So today, Darryl and myself, we are going to talk about how government on commercial cloud does infrastructure as code at scale. So I've never done a code presentation before, so apologies if there's some awkward silence and all that, but we'll try to work through that. So apologies in advance. Right, so I like to start off the story by showing this slide. So this was an excerpt from then former Prime Minister Lee Hsien Loong, who basically made a statement that the government systems can start using commercial cloud moving forwards. So this was done in a statement in October 2018, and I felt that that was actually quite a significant moment because it underscored three things. So one thing is it came from the head of government, which of course, where governments are concerned, always makes the bureaucracy and things flow a lot smoother. So we get agencies to cooperate better. The second thing was it not only mentioned about government systems moving to cloud, but it also talked about the government taking on a cloud-first policy for new systems moving forward. So these are like the three things that I felt that were very important that this statement underscored, that we had support from the head of the government, that we're going to migrate systems to cloud, and lastly, we're going to undertake a cloud-first policy. So when this mission started, beginning of 2019, the target was to move about 70% of eligible systems over to cloud, and that was back in, and we managed to achieve that in 2023. So fast forward a little bit, now we are already at 82% as of February 2025, and I think latest, I think I heard somewhere around 85%. So definitely we have slowed down a little bit because that's simply because we are at the tail end of cloud migration. So all these systems that are running on commercial cloud are supporting part of that 95% of government transactions that are being done digitally end-to-end today. So this is very significant. There's a lot of these systems which are supporting government transactions all running on commercial cloud. So for GCC, where are we today? So again, as of about 2024, we are close to about 5,000 cloud accounts. This is across all three cloud service providers, AWS, Azure, and Google Cloud. And the total number of cloud resources that are contained within these cloud accounts number into 1 billion, probably a little bit more than that. That was just an estimate, of course. So you can imagine the number of cloud accounts and the number of resources that are being managed by these cloud accounts is definitely quite significant. Okay, so this is a good segue now for me to do a short introduction. So my name is Ming. I am Director of Engineering at GovTech Singapore. So GovTech Singapore, as you all know, are the builders and as well as supporting many of the digital services across whole of government. My group, Darryl and my group, so we are from Core Engineering Products. So we basically build and maintain engineering tools and platforms for the government developers that work on government systems. So GCC, of course, will be one of them. So I'll pass on to Darryl for an introduction of himself and his role in GCC.
Yeah, but very good afternoon to everybody. My name is Darryl. I'm a DevOps engineer at GovTech. So at GovTech, on the government commercial cloud platform, I lead a lot of the automation initiatives that we do to provide and provision a good user experience for our end-to-end customers. So that means provisioning from the account all the way to the developer experience at our own engineering team. I'm very happy and excited to share some of the work that we have done and some of the design decisions that we've made along the way to make all of this possible.
Right. Thank you, Darryl. And so am I very happy to be here on stage today. So moving forwards, let us talk a little bit about the timeline so far in the history of government on commercial cloud. We started with the version 1.0 around 2019. So this was a vendor delivered system. And for various reasons, we have decided not to continue with the vendor solution and instead take that development back in-house. And one of the critical few reasons why we decided GovTech should take it back is because we view cloud management and cloud infrastructure as basically one of the crown jewels that we need to hold very tightly. So if we can have the development done within GovTech itself, not only can we have better ownership, be more agile and all that, but we also can have some of that control that we have always wanted to, central visibility and all that across whole of government. That's why we took it back. There will also be some other reasons that I will talk briefly about in the subsequent slide. So I'll move ahead first. So Darryl, who is part of the inaugural team behind the second version, GCC 2.0, basically we formed that team, and then we got to supporting AWS as our first step. That was sometime in May 2022. Then shortly about 6-7 months later, we added the support for Azure Cloud, all right? And then in July, the following year in 2023, we supported the Google Cloud Platform. So now we are across all 3 major cloud service providers. Then in August 2023, GCC2 started to support a sovereign cloud, right, which is basically using AWS dedicated local zone. It's available, you can Google for it online. And we did it quite quickly. If you notice, July and August, that's only like maybe a month or 2 away. And we were able to do this because we leveraged a lot of the IAC that was originally built for the AWS platform and basically used it on the dedicated local zone. That's why we were able to do it quite quickly. Then last year, I would say the team kind of did a lot of clearing out of technical debt and also a big upgrade of our platform to do basically 2 things. Never mind the words, but basically what it means is that we have now achieved the ability to basically bootstrap our entire cloud landing zone as well as the vending machine, all using IAC as well, down to setting up the pipelines and all that we use. Previously, we had to do some of this upfront. Then the IAC code is used to do all the account vending stuff later. But now we have actually went back and did IAC for the entire setup. So now we can basically IAC the whole thing anytime we want. The next thing that we did was we moved everything, all the platform baseline pieces into a mono repo. Previously, they were separated out into different like network, identity, security, and all that. So we brought all of them back into a mono repository. So we have better control over the versioning and also so that our CI/CD pipeline can be more predictable and more visible. So Darryl will talk a little bit about that later on. So that's most of the work in 2024. Then in 2025, I would say at this point, GCC 2.0 is pretty much done up, right, in terms of the internal infrastructure. Of course, we continue to make improvements and we add features to our cloud management portal. But one of the big pieces that's coming out, obviously, is to think about whether or not we should start supporting other cloud service providers moving forwards. And Pan Yong, in his earlier presentation, talked about AI as well. So there's also some work about thinking, so can we use the same platform to basically baseline and stand up AI-related services, just to make it easier for developers. So these are some of the things that we are thinking of in 25. Okay, so you might be thinking, what is the government on commercial cloud? So this pictorial hopefully helps to explain what I mean here. So we all know it's very easy to get a cloud account from any of the CSPs, but we also know as an organization that cloud account can't be used directly without baking in some of those things like, okay, are you gonna have central control over your identity? How are you going to make sure the cloud account is secure? How are you gonna do networking if there's a need to pipe it to your enterprise network? How do you do central logging and monitoring? And how do you do billing? And billing is an interesting one, which you all might find it strange. But here in GovTech, when we operate our platforms, we do an internal charge back to the agencies. So there is a need to make sure that there is automation behind how we generate billing reports so we can apply the enterprise discount appropriately and then we can bill the agencies. So this is actually an important part of GCC because generally billing finance is quite onerous in the government. Okay, so then on top of that, we also need to provide a set of common services. So one of the common services that we have is basically PIM, Privileged Identity Management. For those people, for agencies who choose to use PIM, they can leverage on this common service. Else, of course, they can use one of the cloud-native methods like AWS SSM to do their cloud administration. So we do need a set of these common services which are optional. Then back to security, we also need to, of course, make sure that whatever logs, security events generated by these cloud accounts get piped to our government security operations center, SOC. So that part is also very important to have. Then last but not least, when it comes to audit and all that, we need to make sure that all actions that are done within the cloud account are properly recorded. So if there's ever an incident, touch wood, or if auditors come and all that, then we have all the necessary logs to review. So all of these needs to be done before we can even talk about putting an application onto a cloud account. And these parts in red, which are circled, is what we meant by account vending, the entire process of setting all this up. And this is the role that GCC plays. Okay? All right, so I talked briefly about GCC 1.0 earlier. I mentioned some of the reasons why we decided to take back and develop things in-house, right? One of the reasons was also because the design principles behind GCC 1 was quite different. It was very gated. It was like tightly reined in and controlled, and every action that you do require an approval workflow and all that. So we decided to turn things around differently for the next version because we value developer experience a lot. One of the things that we did was basically guardrails over street gates. So imagine you are, going to the airport, you're driving in your car, you're already late for your, for your flight already, and you don't want to be stopped by a traffic light every 10 meters in your journey. So you prefer there are as few traffic lights as possible, but then there are signposts along the way to tell you to, hey, slow down, speed up, watch out for a turn ahead, there's a car in front, You like these kind of things as a developer that tells you what to watch for along the way rather than stop you and slow you down. So that's what we meant by guardrail over street gates. And Darryl will talk a little bit about that, which is our policy as code, which is one of the things that we consider as guardrails. Okay. Then we have decentralized enablement via platform. Okay, long word. Simply, this means making things as self-service as possible. So we view government on commercial cloud as a platform where developers come in and use it, and then do whatever they need to do. Then, very importantly, we want to get out of the way as soon as possible. Which means me, as a owner of GCC, one of the things that we value a lot is how much time do developers spend on our cloud management portal. We want them to go in, do whatever they need to, and stop using it as quickly as possible and go back to do the rest of whatever they need to do to configure and set up their cloud workloads using the native consoles instead. So this is a very big difference between trying to control and wrap everything, using your own self-service portal. We don't want that. We want to only wrap and control workflows only for the essentials, then quickly get out of the way, and then let the developers continue to do what they need to do. All right. So unfortunately, not everything, of course, can be done this way. There are certain pieces, the core essentials, that we do still need to hold some central control. So this is what we call essentials. So essentials would be things like we want to make sure every account that gets vended, like I say, has a proper service control policy, Azure policy, whatever it is, baked in. We want to make sure the SSO is always linked to our government identity, and there's no way to change that. And we also want to make sure things like central logging and all that is enabled. So these are just some examples of what I meant by essential. So these are the only gates within the government on commercial cloud. All right, Darryl, you want to go ahead and talk about
absolutely.
automation?
Yeah, and I think to support some of these principles over here for us, automation by default is not really so much as a principle that we chose, but something that we kind of had to do with our lean amount of developers supporting across up to 4 cloud service providers, as we have said just now. To support even workflows like decentralization as well as centralization, we're looking at a lot of ensuring that the same actions are being taken and then placed into our multi-cloud environments. So to us, everything is automation by default first, and whatever can't be automated will be managed separately. And that's not a lot to us in our environment, given the amount of workload that we have. I'm not going to dive in too much into policies as code. I think Ritesh has done a great job at that already. But this marked a paradigm shift, right, from just talking about a static cloud environment into one that is constantly evolving. For us, the ability to have policies as code, or rather the principle behind policy as code, is for us to recognize the fact that as the cloud environment evolves and as the services changes, we're able to keep up with that, and we're able to create the kind of resources and environment that our customers need. So that's what policies as code do for us, at least to that extent.
Okay, great. Thank you, Darryl. Yeah. So now you probably already imagine how IAC is going to help achieve all of these within the government or commercial cloud platform. So these next few slides are just some examples. So back in 2023, for example, the logging appliance that we were using had some scaling issue. So through IAC, we were able to quickly test a version and get it released out pretty much under a week. So if you imagine you using manual ClickOps method, that would have taken a long time to do for the thousands of accounts that we have. So similarly, in 24, we found an undocumented limitation with one of the cloud service provider APIs. I shall not name who and what API that was for, but it happened. So the team had to quickly make a change behind the scene. And again, this was pretty much rolled out without any downtime to any of the cloud accounts through the use of IAC and, of course, state management. And in 25, we have another third-party application, which is part of our government non-commercial cloud platform, hit again another scale issue. So similar to the first one that I imagine, we were actually able to resolve it. We detected the issue, resolved it again, fixed it using IAC even before anyone noticed there was a problem with it. Then lastly, in 25, we basically revamped the way that we were piping logs over to the log integration platform. I'll talk a little bit about that near the end of the presentation. And that was basically done in 2 stages, but basically the deployment all happened again behind the scenes overnight, again to thousands and thousands of accounts. So by now, you'll probably already imagine, without IAC behind the scenes, it will be quite impossible to do this so quickly and safely, very important, safely and repeatably. Yeah, that will be quite hard to achieve without IAC. So I wanted to talk about this importantly because we should not view IAC as just something that helps for the building part, but it's also very, very helpful for your day 2 operations as well. All right, so for the next few slides, I'm going to hand over to Darryl, who will talk a little bit about the technical considerations and the design behind how the pipeline runs in GCC. Over to you, Darryl.
Yeah, thanks. So Saming shared a bit about the benefits of how we make use of IAC within our environment, but I thought numbers would paint a better picture for us to really see what's going on, at least within our environment. From an automation and self-service perspective, today we are vending cloud accounts to our customers in as little as 30 minutes and often below 15 minutes. Compared to the dark ages where we spent between 5 to 7 working days to deploy something, this is an activity that we went from basically doing right before we left for vacation to competing with other service providers like McDonald's. From an agility standpoint, our deployment frequency today is about 20 times, actually more than 20 times every single month. And on average, that's more than once a day. And that's really made possible because of small incremental changes through continuous integration. And that really is quite different as compared to the past when managing across several components, logging, monitoring, compliance, all of that usually came together in the past over 2 to 3 months before I make one single production deployment. Today, that has changed quite significantly, and even our lead time for change is below 1 single day. That means it is very real, there's a very real possibility right now that one of our engineers are merging their code changes to the default branch, and that code change will hit production by tomorrow. That's what's happening now. And from a recoverability standpoint, our internal mean time to recovery today stands below 4 hours. That's within the industry benchmark. That is made possible because of a point-in-time type of recovery that we can do thanks to IAC. Rather than trying to figure out what went wrong, having a platform landing zone that versions our entire platform at any single point in time allows us to make quick reverts when we need to in order to achieve this sort of recoverability. Consistency. I think we take quite a bit for granted today because of IAC, that when we deploy something, it will always be the same outcome. That is what we get out of IAC. Before that, we were looking at between 1 to 3% of uncaught edge case, mainly due to human errors, mainly due to certain type of exceptions that we didn't think about before. That was back then. Today, we're looking at 0% because basically we're making use of IAC. And it's quite incredible how perfect infrastructure deployment can be when you remove developers from the loop. Myself excluded, of course, right? And those were the numbers. Those were some of the benefits. I want to dive a little bit deeper into how GCC manages thousands of cloud accounts within our environment, and perhaps some of the design decisions that we made along the way. Our stack over here consists of Terraform. I mean, we're here, right? So our stack over here consists of Terraform. That is our main IAC toolchain. We make use of GitLab as part of our Singapore government tech stack to deploy this IAC code into our cloud environments, the 3 main cloud providers that we use today. Open Policy Agent is our tool of choice to ensure that each deployment that we make is safe, and it's the ones that we need to do in order to not break anything. And I'll go into a little bit about what happened in the past as well and how we fixed that with Open Policy Agent. And maybe a quick call out as well. Well, these are just tools. We spent a lot of time with our partners, HashiCorp, GitLab, and our cloud providers to enable a lot of all this automation that we have today. Our scale is not too easy, and we really thank them for their support in our journey to automation. So diving a little bit into our key components of cloud deployment, we have three primary parts over here: the platform landing zone, the configurations repositories, as well as the continuous deployment pipelines. And Ming has shared a little bit about the platform landing zone, but I want to dive in a little bit deeper over here. The platform landing zone is a single mono repository that consists of every landing zone that we have within our environment. The landing zone being the well-architected set of cloud resource, which we will take a blueprint, if you will, deploying into our cloud environments hundreds of times and literally thousands of times repeatedly, managing that process. It runs the entire cloud platform. And prior to doing it in a mono-repository style, we used to do it in a multi-repository. And for those who are familiar with the argument about mono-repository versus multi-repository, it's really a function of how can we move fast and how can we create good levels of isolation. For us, the decision that we made is that in a cloud environment, your logging is going to interfere, or it's going to be integrated with your monitoring, which is going to be integrated with your IAM, which is going to be integrated with every other thing. So there is no two ways around it. Deployment of IAM or changing of an IAM rule will no doubt affect the rest of the parts. So by putting everything inside a single landing zone and having a consistent workflow for all of our developers, we're ensuring that every deployment works as it should, and we're ensuring that if it doesn't, in the case that it doesn't, we're able to bring the entire platform back to a point in time where it used to work. If the platform landing zone was a factory, in a way, containing blueprints of what we want to deploy, the configuration repository is something that orders from the factory. And for us, the configuration repository is where we diverge a little bit from the platform landing zone. Where we have one platform landing zone for the whole platform, we have one configuration repository for one cloud account. And if you caught what Ming just checked just now, we have more than 5,000 cloud accounts as of now. So that is a lot of configuration repositories within our environment. And the reason why we do that really is because, I want to say it's because we can, but no. The reason why we do that is because we are configuring all of the cloud accounts and in an isolated fashion, where it doesn't affect one another. So each configuration repository using map to one cloud environment really just maps to a landing zone, and then you deploy it through. So we use the configuration repository for basically everything: our own central cloud account configuration, our own central applications, our tenant's cloud account, and even account vending. So we make use of configuration and landing zone to even manage configurations. Putting them all together, it looks a bit like this, where we're looking at a configuration repository, triggering a change, pulling the right landing zone from the platform landing zone, pulling the right version, and ensuring that it goes through the open policy agent to create a safe deployment into our cloud environment. It's quite simple, if I like to put it myself that way. And that was just a little bit about some of the things we did. I wanted to take some time to dive into a bit of the lessons that we've learned along the way, as well as the design decisions. In 2019, there was a very interesting Terraform provider that was released for the public. I'm not sure if many of you have heard of the Domino's provider. Yeah, I think it's quite interesting. Basically, you're able to provision a pizza to your client side. And the unfortunate thing is, if you read the documentation, for those who are familiar, the only way to destroy the resource apparently is through the client side as well. So we have went quite far beyond that at this point, and a lot of us know right now that Terraform providers are things that we do not choose lightly. And even then, for a lot of the providers that we use today, not all providers are created equal. Some of them may have very interesting behaviors that we have to account for, and some of them are exciting but a bit less reliable, and sometimes the other way around as well. For us, we choose our Terraform providers very carefully, and we limit the type of providers that we use, even though they can be really exciting. At one point of time, we were basically saying, let's just Terraform everything because we could. Right? But that, of course, wasn't always the right choice. So for us, we do not just add another provider as and when we like. We are quite careful and stringent about the choice of providers that we use, because if there are limitations or restrictions behind them, we have to work around those limitations. Another thing that we grasped quite quickly was hierarchical deployment. For many of us over here, I'm not sure how many of you have embarked on a brownfield project of trying to terraform your environment, but that was the case for us at some point. So what typically happens is that when you launch your first Terraform state, you usually reference back to your cloud environment. For instance, if I wanted to create a new subnet for the first time but I have an existing VPC, that's what I'm going to do. And along the way, you get really ambitious. I'm not just going to do one small component. I'm going to Terraform and IAC everything that we have under the universe. And you say that we are not going to rely on the cloud environment for a data source anymore. We're going to make use of Terraform for the initial Genesis type of resources, and we're going to refer to that. And then before long, what typically happens as your environment grows is that you have quite an insane type of dependency cycle where we don't even know what's referring to what anymore. So that was the case for us at some point. And because of this dependency hell, so to speak, what tends to happen, despite you saying that we are not going to refer back to the cloud environment anymore, is that somebody is going to do that. So having learned that lesson, one of the things that we learned quite early on was to create a method to this madness. And our method to the madness is simply to create a pipeline that enforces the hierarchy, ensuring that when we're making a deployment, it starts from the top, from the central accounts, down to our management groups, down all the way to our tenant accounts. So rather than just relying on something else or some sort of policy, human policy that is not policy as code, we're relying on the pipelines to manage that hierarchy for us, deploying that perfectly every single time. And the last thing, and I'm not sure if everybody has got the memo by now, but declaration can be destructive. Right, and we learned that, we didn't learn that on the job, by the way. We knew that from day one, right? But the way that we chose to use IAC in general was to basically manage everything, and that includes destruction as well. So the reason why we put an open policy agent right there is just to ensure that there's a safety, and it's not to say that our APIs that deploy things into the configuration repository wasn't right. It was right. But at some point of time, a couple of years ago, what happened was that there was a race condition that resulted in a difference in what we wanted to deploy, and that created a form of destruction to some of our resources. So we learned quite early on that policies, in a way, if it's over there, it has to be written, and in some cases, the policies has to be refined along the way, and we call that policies which is written by battle, right? Policies which are written by war. So right now, all of our deployments, they'll go through the open policy agent, especially for very, very dangerous deployments, right? Just to ensure that it is deploying what we want to deploy. And there's a little bit about our architecture of how we do our deployments across the cloud environments.
Yeah, thanks you, Darryl, and that's why I have to bring the engineer on stage, right? So, all right, so now my turn. Okay, so I'll finish. This is the last part of the presentation. So, just want to walk you through very quickly some of the very common things that we do during deployment, all right, which Darryl might have talked a little bit about. So, the first, of course, which is account vending, and that starts with a user interacting with that cloud management portal that you see on the left. And through that, then basically, the user does an action. I want an account. The GitLab pipeline triggers, and it takes from our central configuration directory to set up some of the baseline configuration that we need, which then results in the instantiation of the cloud account. And then you see all the pieces, the essentials that I talked about, the CloudWatch, the central login, and all that being set up. And this action will then create that account-specific configuration directory from which we'll start to keep state-specific information, variables, whatever it is, for that particular account. So that is going to be part of that hierarchy of deployment that we will use later on if there are going to be changes done to that account. Right? The next, of course, would be after you provision an account, many teams will go in and say, oh, I want to create a compartment that can connect to our government enterprise network. And the same flow happens again. The user will interact with the cloud management account. Again, it goes through the central configuration directory, then the pipeline runs, and then we will set up the appropriate connectivity, the compartment, as well as the CIDR ranges and all that to make sure that it can reach the government TGW in this case, using the AWS term. So, sorry, and maybe before I jump to the next slide. So we will then, of course, then write and be able to keep track of which cloud account, which compartment, and which CIDR ranges these cloud accounts actually have. Okay. The last part is that example that I mentioned about how we did our integration to our central logging infrastructure. So that was done actually in two stages. There was the first stage, which again the cloud The government on commercial cloud administrator will run the first set of Terraform to set up the basic central infrastructure for logging. So this is actually being done inside of our central account. So that's the first stage, sets up the framework and all that. Then the second stage is where we then initiate, again through the GitLab pipeline, and we basically spray all the necessary changes across all the thousands of cloud accounts that we have, and get them to connect to this central framework. And these two stages basically completes the entire integration effort over to this new logging infrastructure. So it was done in 2 stages. Right, so and really that's about it. So thank you again for listening to Darryl and myself. If you want to find out more information about GCC, feel free to scan the QR code or visit our Singapore Government Developer Portal. All right, thank you, Darryl.
Thank you very much.
Yep.